Let's solve this question that is based on mole concept. We know that number of moles is equal to mass divided by molar mass, and that is equal to volume divided by molar volume. Number of atoms or molecules is equal to number of mole times Avogadro number. 16 gram of methane is given. That we cannot compare with weight. So therefore we can't compare with 1 and 3. Either it has to match with 2 or with 4. And we know that if it is 1 mole, the molar volume has to be 22.71 liter. But here half of that value is given. In 16 gram of methane, how many moles of methane will be there? We will have 1 mole, isn't it? Because mass is given 16 gram. Molar mass of CH4 is 16 gram per mole. 12 plus 4. So that means we have 1 mole. So 1 mole means we should have 22.71 liter. So therefore we can compare that with 4. We have to compare with 2. 1 molecule of methane will have 10 electrons, isn't it? So here we are having Avogadro number of molecules times 10. So that's why 60.2 times 10 to the power 23, which we can write it as 6.02 times 10 to the power 24. So therefore A has to match with 2. If that is the case, 3 is wrong. In 1 gram of H2, we once again cannot compare that with weight, and we can compare with 2 also. So we have to compare with 4. 1 gram of H2 means half a mole of H2. That would occupy 11.4 liter volume. So this means 1 is also wrong. In 1 mole of N2, what would be the weight? It would be 28 gram, because molar mass of N2 is 28 gram per mole. So therefore C has to match with 1, which means option 2 is correct. 0.5 mole of SO2. 0.5 mole of SO2 would weigh 32 grams, because 0.5 mole times molar mass of SO2 is 64 gram per mole. So therefore 32 gram, which means option 2 is definitely correct.